add my solvent, which in this case is water. So I'm going to add a significant amount of water because I'm making a dilute solution. Then I'm going to take my glass rod, which we use to stir.
Dear audiences, I am Gobez Academy and this is my colleague Radit Salomon joining you from our chemistry laboratory.
Today we're going to demonstrate a few experiments and we are very excited about that.
Yes.
And I hope you are all excited as us. So today the objective of the experiment that we're going to perform is to prove or show or confirm that chemical changes are often accompanied by color changes.
Yes.
So before we go right ahead to our experiments, let's prepare our chemicals and introduce you to some of our instruments, shall we? Now I have here, as you can all see, a beautiful potassium chromate. This potassium chromate is in solid form and it has a beautiful yellow color. Now I need to make a solution out of it, so I'm going to pour it into my beaker. Now the beaker, we're going to use it in this experiment as chemical reactions are going to take place in the beakers. So I'm going to take it and when we are making a solution, we always put the solute first. So I'm going to scoop it using my spatula. A spatula is an instrument in the chemistry lab with which we use to scoop chemicals out because we never touch it with our bare hands as it is toxic. So I'm going to scoop it. I'm going to add a few drops. Okay. Then I'm going to add my solvent, which in this case is water. So I'm going to add a significant amount of water because I'm making a dilute solution. Then I'm going to take my glass rod, which we use to stir. Then I'm going to stir my chemical. As you can see, the potassium chromate is slowly but dissolving in the water and it is forming a solution. And it has still retained that beautiful yellow color of its. Okay, so here I have my potassium chloride solution.
Yes.
Then I will need a hydrochloric acid solution. So I have here, as you can see, a dilute hydrochloric acid solution. Now, when we are dealing with acids, be careful that they are dilute. Fortunately, we already have a dilute hydrochloric acid in this lab, but in your laboratory, if you only have concentrated solutions, be sure that when you dilute it, add the acid to the water, not the water to the acid. So,
yes.
Because I have a dilute, no need to dilute this anymore. I'm just going to add it into my beaker. And as you can see, hydrochloric acid is a colorless acid. So be careful when dealing with it because you might mix it up with other chemicals such as, the
Yes, like the water.
Yeah,
yes.
the water, because they are both colorless. So be careful when dealing with that.
As you can see, I have a beautiful orange colored solid here and the name of the solid is potassium dichromate. I'm going to make a dilute solution out of this potassium dichromate. So I'm going to add some with my spatula to my beaker. Yes, this much is enough.
Okay.
I am going to use water as my solvent. Yes. I'm also going to use a glass rod to stir it.
Okay.
It's slowly dissolving.
Okay.
It's going to take some time, but it will dissolve fully.
Yeah. What can you say about this color?
Yes, it's still orange,
Yeah.
as you can see. It's still orange. And the next solution I'm going to prepare is a base.
Okay.
Sodium hydroxide base. As you can see, I have got a sodium hydroxide chelate here, and I'm going to make a dilute solution of this base. Let's scoop up some chelates.
Why are you using a spatula?
Because if I touch it with my hand, it's going to dissolve with the moisture on my hand and it's going to be toxic.
Okay.
Yes. I think this much is enough.
Okay.
Yes. I'm also going to use water.
Okay.
I am going to use another glass rod in order to stir it.
Okay.
This is also going to dissolve slowly. Yes. That it will eventually dissolve. So,
Okay. It has dissolved, I think.
yes.
Yes.
This is a sodium hydroxide solution.
Yes. So now that we have gotten our chemicals prepared,
Yes.
and we have introduced our instruments to our audiences, let's go ahead and proceed with our experiment, shall we? So I'm going to mix together the chemicals that I have prepared here. Now I have here a beautiful yellow potassium chromate solution, as you can see. So I'm going to take my hydrochloric acid and I'm slowly going to pour it into the solution. Let's see what happens. Wow, interesting. Interesting. It has totally lost its color.
Yes.
And changed to orange, similar to yours.
Yes, my dichromate's color.
Yeah, interesting.
Yes.
Okay, let's see what you can do with your chemical.
Yes, I am going to add this dilute sodium hydroxide base to my dichromate solution.
Okay.
Let's see what happens.
Okay. Interesting.
It has changed its color from orange to yellow, which
Wow.
is your chromate's color.
Yeah.
Yes.
So, what is our generalization from this experiment, Keva?
Yes, chemical reactions are often accompanied by color changes.
Yeah.
Yes.
So, let's analyze the reactions that took place here based on our generalizations. When I had, first of all, I had a potassium chromate solution, which was yellow, as you all remember. But when I added hydrochloric acid to it, it reacted with the hydrogen ion from the acid and it turned to dichromate. This was proven by its color change from yellow, which is chromate's color, to orange, which is dichromate's color. What
Yes.
about in your case?
Upon the addition of sodium hydroxide base, which was dilute, the dichromate changed its color from orange to yellow. This confirms the presence of chemical reaction between the two species. The dichromate was changed to urochromate. This was also confirmed by the color change, which was from orange to yellow.
Okay, so we have proven that using our chemicals. I first had a chromate. Okay, then so I have here a chromate. It's reacted with the hydrogen ion from the acid, then it formed a dichromate. And also water. So, on the audiences, as you can see, this is the reaction that took place in my experiment. So, what about yours?
I had a dichromate originally,
Okay.
which was, and it reacted with the hydroxide ion from my dilute base, and it was changed to urochromate. Yes. It also gave us a water. Yes. To show this to our audiences, I originally had a dichromate which had a color of orange like this, and I added as a dilute solution of hydroxide base, and it was changed to a chromate solution which had a color of orange. So So this is the reaction that took place.
Yes. So to summarize our reaction in a simple way, when we have chromate -2, it is a reversible reaction into dichromate -2. Then from chromate to dichromate, it is changed by an acid which has H plus or hydrogen ion in it. And from dichromate to chromate, it is changed by a base which has hydroxide ion in it. So this is the summarizing reaction for the experiment that we just did. To explain again, when I have a chromate and to change it into dichromate, it is a reversible reaction. It is a reversible reaction. It is changed from chromate to dichromate by the use of an acid which has a hydrogen ion in it, and is changed from dichromate to chromate by the use of a base which has hydroxide ion in it.